looking to build an automated data pipeline on Snowpark, this is our hands-on lab. We are ascend.io. We build automated data pipeline solutions, and we are more than happy to share with you how you can be using Snowpark in a more efficient way today. My name is Paul Lacey. I'm the head of product marketing here at ascend.io. And then the real smart person in the room is Ayush. Ayush is our field data engineer. Yeah, Ayush, welcome. And he's going to be spending most of the time going through the great content that he's prepared for us here today. Can't wait to dive into it. But yeah, thank you, Ayush. Great to be with you.
And Paul might have said I'm the smart one, but he's definitely the one that'll talk you through a lot of the basic overview and what you're going to be seeing here today. So I definitely still listen up.
You're too kind. So our agenda for today, we're going to start off with what is data pipeline automation. A lot of people get what automation means, but we need to be a little bit more specific on what it is that we're really looking to automate here. So we're spending a little bit of time on that. We're going to spend a little bit of time on what it takes to create that kind of an automation. And then we'll dive into the meat of why Snowpark for data pipelines. And we got a lot of great information for you there. And then we'll finally go and actually build a data pipeline that can be automated using Snowpark. And that's going to be the real fun part where we actually start to dive into the code. And if you wanted to open up your own code editor or your own Ascend demo environment and start following along with us, that's where you would do that. And then finally, we'll wrap it up with a little bit of Q&A. Although we'd like to treat these as very informal sessions. So if you have Q&A as we're going through, please go ahead and pop the questions in the chat. So what are we talking about? What do we mean when we say we want to automate data pipelines? So I want you to imagine you're a data engineer and you've been working in your job for quite some time. And so there's more than one data pipeline that's running in your organization, right? There's probably more like a network of data pipelines running at this point. Your data pipeline situation probably looks something like this. You've got a number of different DAGs that are in various discrete data pipelines, but then they all create data sets that are then inputs to other downstream data sets or data pipelines or DAGs, if you look at it that way. And so it starts to become a little bit complex. We start to think about how we maintain this. And then, the real question is what happens if you want to make a change to one of these pipelines that's in the middle of all of this, right? So raise your hand if you've ever spent any amount of time on impact analysis as a data engineer. And I know that we're in a webinar, so a lot of people can't raise their hand. Some people do like to use the hand raising feature when I ask this question, which is fun. But yeah, lots of us have spent a lot of time doing this kind of what's going to happen when I make this change, not just in this particular pipeline, but in all the other downstream pipelines that are dependent on this. And that starts to get really complex and really tricky, thinking about where do I need to go kick off reruns of pipelines? What data sets are now out of date and obsolete? What schemas need to change? All this different kind of stuff that happens when you want to make a simple change. Now, the change itself might be something rather trivial that could take only a couple of minutes, but doing this impact analysis could take hours, or in the worst case, even days, if you don't have good governance and visibility in place, observability in place. So the easy button, or what we really want to be able to automate here with an intelligent control plane, is to say, hey, if we don't want to make a change to a particular node, and we know that there's a lot of downstream nodes that consume this information, they may be across a number of different pipelines. We don't really care in this particular instance that there are in different discrete pipelines, because we just know that they consume this data that's downstream of the change that we want to make to a particular data set. Imagine if we had a data controller that could just automatically understand that was going to happen and what needed to happen as a result of that. And you'll see, we can imagine that the change just flows through the network, and then the data sets get refreshed and different jobs get kicked off automatically to go ahead and refresh different parts of those data sets. And only the parts of the data set, like notice we're not rerunning entire pipelines here. We're just updating specific transformation nodes as the changes need to flow through the system. And that's an incredibly powerful way of thinking about things and thinking about the world and automating some of the changes that we want to be making to our data pipelines on a regular basis. So we're automating the orchestration of these pipelines, and we're automating the change management, change propagation throughout these different pipelines as we start to look at it. That's what we really mean when we talk about data pipeline automation. We're really also talking about the elimination of manual orchestrations. This is a kind of real world example. Imagine I've got this transformation here. It's using some SQL logic, and the SQL logic defines business cases. I say, hey, I need to update some business logic. I go and make that change. And then the system automatically kicks off and says, I know that this change was made. I know that this data set needs to be recalculated for this particular step, but I also know all these downstream steps also are going to be impacted by this because their data sets need to be reprocessed as well. And so it automatically kicks off and starts running those jobs. There's no searching through Airflow DAGs to figure out which ones are dependent, which ones need to be rerun. There's no waiting until the nightly batch rerun or reprocessing to make sure that all of this stuff happens. So nobody can trust the data until after all the reruns have been done. It automatically just pushes it through the system and then shows you exactly where and when conflicts occur and what needs to happen in order to manage them through those conflicts. So that's super, super powerful. What do you need to do in order to create this kind of manual orchestration? Like if we were to set out to say, hey, I want to build a pipeline using lots of Snowpark transformations, and I want to be able to automate that pipeline. So when I make a change to one step, it automatically just updates and refreshes everything, and all the downstream data sets are reprocessed as well in a smart way. So it's not driving up a bunch of compute. You need three things. You need an integrated tooling platform for all steps in the pipeline. So you need your ingestion. So being able to go out and grab data from different sources and refresh that data on a particular interval. You need that ingestion piece. You need the transformation components, which we're going to be spending a lot of time looking at in Snowpark. So doing these Snowpark transformations to the data, we need to be able to reverse ETL the data back to the different destinations where it might want to land and live throughout the organization, whether those are operational databases or other SaaS applications where you're actually enriching the data, like a Salesforce, for example, we're enriching different records in Salesforce with this information that we're processing. And then all the orchestration and or scheduling of these data pipelines, all this stuff needs to be hyper integrated in order for this to happen. So there's two ways to do that. You can either use a platform that has all of these components in one, and then you get a natural integration by the fact that all these things happen in the same place, or you can use lots of different point solutions, but you're going to have to do all the work to integrate these different point solutions together to make sure that happens. And then also make sure they're sharing metadata, because the real way to achieve this high level of automation is with a huge amount of metadata about the data sets. What partitioning strategies are you using so that you can only reprocess partitions that matter, not the entire data sets, which, as you can imagine, might start to drive up a lot of compute. But in this case, we're able to significantly reduce compute using really smart partitioning strategies, matching code versions to data sets. This data set was processed by this version of the code, but now we're on this other version of the code. So therefore, this data set's out of date. And then the intelligent controller can then use that information to say, aha, I need to kick off a job to go reprocess this data set. And then finally, you need that intelligent automation controller that is constantly looking out over the domain of your data and understanding what needs to happen and when in order to bring this whole system back up to compliance, whether it's new data that needs to be processed or whether it's old data that needs to be reprocessed because a change has been made. All of this is required in order to achieve that kind of change management, propagation, and automation around that. So that's the theory behind it. Now let's have a little bit more fun and let's talk about how you build these kind of automated data pipelines, assuming that all these components are in place, right? We're going to take these as pre-existing conditions. We assume that we have all of our steps of our pipeline fully integrated into a platform. We assume we have all the metadata required, and we assume that we're using an intelligent automation controller. In this case, we're using the controller on the Ascend.io platform, and then we're going to go forward from there. So Ayu, take it away, sir.
Yeah, thank you for that segue, Paul. And now we, as you can see on your screen, we'll start talking about Snowpark versus SQL. But what Paul gave you was really an overview of what Ascend as a platform achieves. So now you understand a lot of the advantages of having the automation of orchestration occur. Because what that allows you to do is reduce a lot of your costs in terms of compute, what you're actually having to run, and all those sorts of things. But many of you, and probably the reason that you're here, are using Snowflake already. So how do you integrate the solutions that you're already using into the Ascend platform to best take advantage of the advantages that it's giving you? And part of that, if you're on Snowflake, where the integration is fairly straightforward on our platform, will come in the form of what is more optimal. Should I use SQL or Snowpark? Luckily, we offer both, so there's not really an issue in terms of using one or the other altogether, but rather in what specific scenarios would you want to use Snowpark or SQL? So let's dive into that conversation and see where that goes for the next little chunk of time, excuse me. And then after that, we'll actually show you a lab where we will demonstrate how exactly you can use that on the Ascend platform and give you more real world examples on how that might actually go. So diving a little bit into what is the thought process or workflow, however you want to describe it, when you're trying to decide between the two, right? The first question you actually want to ask yourself is, can I use SQL, right? These two libraries, so Snowpark and then Snowflake SQL, are predicated on the idea that SQL and Python are the go-to languages for data engineering as a whole. With that being said, SQL is generally a lot easier, a lot more people know it, and so generally the barrier of entry is a lot lower and makes it a lot easier on the user to be able to use. So we would probably preferably want to use SQL. This also comes with added benefits of Snowflake and many other compute engines, making this a much more efficient query because SQL is a declarative language. So they're actually able to take advantage of that and optimize the query more so than maybe your user-defined function in Python might. And we'll get a little bit more into the nitty-gritty on the next slide, but that's why we're starting off with SQL and then flowing into Python. Given that we're starting with SQL, it's pretty straightforward from there, right? You're just starting with the yes or no question, can I use SQL? And if it's yes, we do strongly advise you to, and I believe Snowflake also is on the same path. Almost anybody will tell you as well that SQL is probably the go-to language. As I mentioned, all those advantages before, but really the easiest one is it's easy to do and it's a lot more optimizable for the query runner. Whoever's running it will probably get the most they can out of the query. But when it comes to Python, the other language that will come as a backstop for more complex queries, more complex things that you need to run, that will be your ability to say, I want to run this, get more advanced analyses, get whatever you really need out of the pipeline that maybe SQL might not be up to par on, and get that to run. And then the last option when you're saying, no, I can't use Python is you probably messed up somewhere in there, right? And so you might have to go and reevaluate what exactly is going on in the pipeline. Maybe your life choices somewhere here and there, but really it just means your pipeline probably is missing something that you need. And because SQL and Python, in this case, Snowflake SQL and Snowpark, should be able to answer basically any part of the pipeline for you and get everything to run as smoothly as possible. So with that framework in mind, what exactly are we evaluating when we talk about Snowflake SQL versus Snowpark? So we have these 4 main bullet points, and obviously there will be much smaller and then the gritty on how exactly each of these is run. But these 4 should cover a vast majority of what you'll see when you try to compare the performance and cost analyses between these two. So we'll start from the top and we'll take a little bit of time here just to get into what exactly it is. And if you have questions, feel free to plug away in the chat and we'll try to maybe hop in even in the middle if there's time to. But for now, let's just focus on these 4. As I mentioned before, SQL is a declarative language, right? In opposition, Python is an imperative language with more iterative logic and the transfer steps explicitly defined. And so for those of you who aren't as aware with what declarative versus imperative is, I'll just give you a brief summary. Declarative essentially means you try to define the end state, and the middle steps on how exactly that end state is achieved is defined by whatever is running it. For example, Ascend is a declarative platform. So what that means is we figure out what the most efficient method is to get to the end state of your transform, the end state of your write connector, to get it to write as efficiently as possible or to run the SQL query as efficiently as possible. An iterative example would say, okay, you are specifically defining each and every step as it should be. And so there's not really room for the optimizer or whatever's running on the back end, the automation, to really take advantage of what it wants to. It's just going to take what you told it to do and run it exactly as that happened. So there's not really going to be too much leeway in terms of, I want to see a lot of cost. Then we come to the second step, which is saying on the SQL side that you're limited to the data transform operations only, whereas on the Python or Snowpark side, you have non-transformation operations allowed. With the previous part, it might have sounded like SQL seems well and truly far ahead, given that all you have to do is define an end state and you get the quote unquote most optimal version of it. But this comes with some cons, right? So in this case, SQL is very straightforward. You're only really able to do data transformation operations, but Python is a lot more flexible and you can take advantage of it in a lot more different ways. So in this case, things like MLOps, orchestration, all sorts of definition processes that SQL isn't really able to do will come in play here. From there, we're going to get into the maintenance side of things. So SQL is very easily maintained. You have expansive function libraries on the Python side. So you get different advantages here and there. So it really just depends on what your use case is, as we mentioned before. And that's why we think that the real world examples that we'll show later on will be exactly the case that you want to take a look at. Lastly, and we've mentioned this in brief before, you're going to be much more efficient by the Snowflake Query Plan Optimizer. This is very advantageous for the querying of SQL. And then on the Snowpark side, this will require developer optimization. So a lot more work has to go into making it the optimized version of what it could be, whereas SQL, Snowflake will mainly take care of that part for you, so you don't have to worry so much about it. And as some of our friends in the company like to say, with great power comes great responsibility. Just make sure that when you use SQL or Python, regardless of which language, what it's good for and what you're going to be using it. And then the part about cost. We've described in very general terms what's happening on the back end. What are you taking advantage of? What is this? What is that? Right? But what does it actually look like? So in this case, on the top right, you're seeing what a SQL query looks like. For anybody who's used SQL, this should be very straightforward, nothing too different. There might be some slight differences in terms of exact Snowflake SQL syntax, but at the end of the day, this is going to be a standard SQL query with not much changing between, right? If you've used SQL, you can use Snowflake SQL. You just might have to change a couple functions here and there. When it comes to Snowpark, if you've used Spark, or even if you use Pandas, for example, or Apache Spark or PySpark, whatever the variation of Spark you've used, they should again feel very similar. There's a reason it's called Snowpark. And so for that reason, you'll see a lot of similar functions here, things like alias, how exactly you're referring to data frames, all these sorts of things will be very familiar. Again, as it is Snowpark's offer or Snowflake's offering, there will be slight variations in how exactly the functions are, maybe what exactly is happening on the back end in terms of query optimization, or how joins might occur, or those sorts of things. But at the end of the day, you're still getting the performance optimization that you want, and it's all occurring within your Snowflake environment. So even if it might look a little different here and there, at the end of the day, you're still getting what you want. So now, how exactly do we make Snowpark work for you, right? So there are very common issues that regardless of whatever language you're using or whatever library you're using in Python, you're going to run into, right? Local development management is hard, right? You are going to have to manage your credentials. You're going to have to manage your schema. You're going to have to switch context. There's all sorts of things that when local development is involved, you're going to have to somehow bring in everything from a non-local environment and say, I want this all defined here with all these steps in between already handled, right? So you have to go through those steps yourselves and make sure that's running for you. Furthermore, you're going to get into mixed mode pipelines that require multiple steps, and we'll go through the solutions of each of these. But for now, just let's consider the problems. Coming back to it, the mixed mode pipelines, right? If you're working with SQL and you're working with Python, then you're working with SQL and then you Python SQL, whatever variation of pipeline that you have, in this case, if we refer to them in transforms in the Ascend lexicon, you're going to end up with a lot of mishmash of this place is optimal for SQL, this place is optimal for Snowpark or Python. All of those sorts of things will occur to you, especially when you're building your pipelines. So you really have to think about if you're in isolated environments of SQL or Python, you have to figure out what's the way between passing between teams, passing between an individual developer in different environments, all those sorts of things that Ascend might help you with. And lastly, the change control and EDL management between environments is hard. As I mentioned before with local dev management, and coming back to it here, you're going to have to handle CI/CD, all these sorts of things that are going to occur in your local dev that you then have to extrapolate out to your remote environments that have to translate easily back and forth without much mistakes or anything really occurring that might stop the development itself. So now that we've addressed the problem, a brief word on like why these are occurring here and what exactly we're going to be doing is, if everything's isolated to a specific environment, as it is in Ascend, if you're able to just use SQL and Python back to back without worrying about what they're doing, as you might do in like Snowflake with a random notebook where you're writing SQL and Snowpark, Snowflake SQL or Snowpark, and those sorts of things. These are the kinds of things that we're talking about, that the resolution of working in Ascend and staying within a singular environment within Snowflake and using the offerings it has, all of a sudden, you don't have to worry about these common issues that occur for literally any developer, right? And so these are the things that we're trying to get rid of by having not only Ascend offering, but also including Snowflake's offerings to make it really easy for anybody to use. So now you'll see what modern Snowpark looks like, right? So this will be exactly what you're going to be seeing when you work with it in Ascend. So in this case, you'll see this will be an inline code editor that you'll get whenever you pop open a Snowpark transform. So you'll have your import, the automatic imports, where you're getting basically everything from Snowpark, including the session, the data frame, any functions or typing. And then you just have to write your own code within the transform, right? It should look very similar to what you do in Spark, what you do in PySpark. Nothing too different. Everything should be as it is, just with maybe Snowpark syntax. So then what exactly are we talking about at the end of it, right? When we talk about Snowpark and having it work for you, when you bring it all into your workflow, what does that materially look like within your Ascend environment, right? You have CLI and IDE integrations for, right? Live credential management, integrated testing on cloud data. All these things are already there, right? You don't have to worry about that. We talked about it before as a problem. Now we're presenting the exact solution that you're going to get, right? You get multiple languages in a single pipeline flow. You get SQL and Python and SQL. You get Python, SQL, Python. You get Python. It doesn't matter what kind of pipeline you have, right? It's just you have a certain pipeline that you want to build. You want the most optimal way to run it, both in terms of costs, in terms of not having to move between teams, whatever you can really think of in terms of just saving time and energy and money. Ascend is really offering that for you by having it all compacted within one environment. You get automated DDL, you get command line git integration. We've talked about this before. This is just what it looks like in Ascend, right? Here you get your projected annual savings. I'm not going to get into the numbers. You might see variations here and there. Any saving is good saving. And you're going to enjoy this when you're able to come to a single environment. And yeah, maybe in terms of material costs, in terms of money, it's 5%. But you have to remember that this comes in terms of how much time do I have to spend communicating with someone else? How much time do I have to move between teams and constantly say, oh, this is here, this is there, moving between clouds, moving between warehouses, whatever it is at the end of the day that's costing your team time and energy. This 5% doesn't really capture all of it. And so all of that combined with the solution on the left and the savings on the right really shows you the power of what Ascend offers and having Snowflake and Snowpark, for that matter, at your advantage as well. So we've talked a lot about what is Snowpark and Snowflake SQL and Snowflake at large kind of doing for you, but why use Snowpark specifically, right? What does the Snowpark offering really give you advantage of over Spark and other sorts of things? You get native integration with Snowflake functionality. As we mentioned, with working within the Snowflake environment, you're going to get native integration, right? You don't have to worry about, is this going to work with Snowflake? If I take a PySpark transformation and we can work with Snowflake and make sure that it's the exact typing, exact functions that are going to work on it, whatever your data frame format is, whether it's a group by format, whatever it is that you're trying to work with, this will guarantee that it automatically works within your Snowflake environment. And you don't have to split the details. Not only that, you get enhanced performance and scalability. As we mentioned with Snowflake, they've got the optimization side of things down. They have had it down for a couple of years, and I don't think anybody is really competing with them in that regard in a lot of ways. There might be one or two here or there, but you come to Snowflake for a reason, right? And that's because they've got a lot of this down pat. And so when you're using Snowpark, you can guarantee that this performance and scalability because you've optimized your Snowflake environment. So when you come to Ascend and use Snowpark, you get that in tandem when you write your transforms with Snowpark, right? So you get your enhanced performance and scalability, you get the added Snowflake functionality and native integration. And those combined give you a unified development, right? You don't really have to worry about, okay, am I moving between environments? Am I going to have to exit Snowflake for a brief period and come back to be able to use it as intended? You just instantly get it pulled into your Snowflake environment as soon as you use it, right? All your data is stored there. All your computers run there. Everything that you can really think of within your Ascend environment that uses a quote unquote engine, you can do it in Snowflake. It's as simple as that. There's nothing to it, not even having to write the code to work within Snowflake. It's all already handled within Snowflake on our platform. So then the ecosystem integration, everything is already integrated. You're going to bring in the tools in your Snowflake environment, whether that's from Ascend to Snowflake or Snowflake to Ascend. Everything becomes integrated. You don't really have to worry about, okay, how exactly am I going to use this tool? What exactly am I going to use this tool for? All this is already integrated. You don't have to think about where and when it is. If you want to bring in a library, bring in a library in the Ascend environment, and we can use that within Snowpark, right? There's not really an issue with being able to use the tools at your disposal. So we've covered the advantages of Snowpark. What does that end up looking like when you're actually working within the environment? And what is your thought process? Right? We started with a thought process. We've worked through what exactly those advantages are. Now we're ending with another thought process now that we've addressed what those advantages are, right? And so here in your Snowflake environment, you set up your environment, you load your data tables, you create your business logic, save new data frame. This is like a fairly standard, straightforward work, right? Nothing too separate, nothing too unique. Everybody goes through this, whether it's in the Snowflake environment or not, right? Just with Snowflake, you might have some particular quirks. But within Ascend, it's really straightforward, right? I mentioned before, when you pull in your data and you store your data, and you use compute on your data, all that is done within Snowflake, we quite literally need that, right? When you use a read connector and you ingest the data, that goes and sits in Snowflake. You don't have to worry about the table creation. You don't have to worry about what exactly is occurring. All you have to do is make sure you're saying, okay, we have this warehouse at our disposal. It's going to be running these things here. This will go and store a table in there for you from Ascend, right? Then you write your Snowpark business logic, use your Snowflake SQL here and there. Boom, you get your temporary tables in there that tell you what exactly is occurring in this transform, what that data now looks like. You get your entire business logic and pipeline written out in Ascend. And all of that runs within Snowflake, where you're able to audit, where you're able to look at, where you're able to take advantage of all these compute resources that you have in Snowflake. So anything that you can really think of in doing in Snowflake, you can not only do in Ascend, but still have the advantages of Snowflake still at your disposal, right? So you went from a multi-step, very not difficult, but very long and tedious process of having to make sure all the things are in place for you, to a two-step process that says you bring in your data and you run the business logic that you want. Nothing more complicated than that. And that's really what we're talking about when we talk about advantages. Regardless of what you think of in terms of monetary costs, this will save you a ton of savings in terms of everything else, guaranteed. Cool. We took around 20 minutes for that to give you like a good idea. So we're going to spend like the next 15, 20 minutes just going through like a build process of what exactly does it look like when he said all these things about ingesting data into Snowflake and pulling all these sorts of things in and working in there, taking advantage of the Snowflake efficiency. How do we do that within us? So our dev tier is free for anybody to use if you're interested in doing that. So please do feel free to do that. There's one thing I'll say before jumping in here. This is predicated on the idea that you have done previous pipelines, so you might not have the connections built out. There will be links in the link that we provide you to go back to that and create that. Feel free to follow along now and just see what's happening here, and then feel free to go back and build it out. It's all straightforward, doesn't really need too many instructions or a live instructor. It's just mainly to get you started, and you can go. Cool. So you should now see a new screen where you're able to see the kind of guide that I was referring to earlier on the left. This is a little complex, so excuse me, but it'll be easier to follow along this way and see what's going on. And then you might see an example Ascend environment on the right. Right. So yours will obviously be a little bit more sparse than having all these sorts of things open, but the idea should be this. Right. And then, as I was mentioning before, the links that I was talking about, so creating a Snowpark pipeline, creating text domain, creating a weather domain, these will be simpler. They might not refer to Snowpark and Snowflake SQL explicitly, but the idea is that you can get more familiar with the Ascend platform, and it'll be a lot smoother and a lot easier for you to run through these things. In the meantime, I'll just go through it. Feel free to follow along and just listen in, and then you can take a crack at some of those. The idea will always stay the same. Cool. So we'll start here. The overall purpose of this data flow will be simply to ingest cab data and weather data. So you can see that we have cabs demo, weather demo. We'll create a new data flow just so you can follow along here. But the idea will be we'll take those two data flows, combine the data between the two, and create a more complex final analysis out of them, that referring to the tipping behavior of certain people, I think in New York City in 2016. You can judge the people back then. But we're just going to be doing that in here. Pretty simple, straightforward data flows that will be taking advantage of Snowflake SQL. And so to begin with, we're going to create a new data flow. If you don't know how that's done, just feel free to, when you pop open even your new environment in Ascend, you should see a new data service. So one of these, and then a new data flow. Just create new data flow. You go ahead and create a new data flow name. We'll just call this cabs live demo. Go ahead and we'll go ahead and create it. So then, as long as you follow the instructions, should be fairly straightforward. But on the left here, you'll see in the ingest or in the create tab, and then in the ingest section, you'll have a read command, right? So then here, this is what I was referring to when you might have to go to early labs for this, but you will want to use the Ascend IO sample data read bucket for the S3 connector. This is a publicly accessible bucket, so you should have access to it regardless of the credentials. Then you can go ahead and use this. We'll go ahead and skip and configure this manually. This will just make it easier for us to just quickly go through this. But then you can go ahead and copy all the information here. Whatever the field name that is referring to. So in this case, name. In this case, for object pattern matching, we have match. Here we can just go ahead and paste everything, but we'll just continue doing this throughout. You'll see it. We'll just end up copying and pasting everything. And this is just so that things are faster. But for any read connector in Ascend, you're going to want to use one of these neat features that we have, which is automatic schema generation. So this will look at the CSV file that we have pasted in this bucket, and you'll be able to take any of these, or take any CSV, and be able to automatically generate the schema that's present there with a preview of the records, the types of the columns, and the names of the columns, right? So we'll go ahead and create that. And you'll see that we'll get clean yellow cabs. That read connector is now up and running. It will go through, list these, and create them. But in the meantime, we'll go ahead and actually get started on the clean green cabs read connector. So we'll pop this back open. Use this same connector or connection because it's still a connection to S3 or the same S3 bucket. And we'll just go ahead and fill out the specific information here, right? So in this case, this will be a prefix map. We're going to get every CSV file in there, in that particular folder, And then we'll say that it has a header row. You get your specifications and the configurations. We'll generate our schema, get it again, go ahead and create it. and boom, we have both our read connectors. This means we've ingested the data. So what we were referring to earlier when we said the data gets stored in Snowflake, you might see and notice here, so I'll zoom in just a tiny bit, is that you'll see that it says S3 to Snowflake. What this means is now this data is stored as a table in Snowflake, right? It'll take me a little bit to go into the Snowflake environment, so it might be a little difficult there, and I can try to show that at the end. But the idea is that all of these will be stored as specific tables within your Snowflake environment. And so there, what that ends up doing for us is saying, okay, now that this data is stored in Snowflake, when we write our future transforms, we'll actually be using that table that's stored in Snowflake. And whatever table you write in Ascend, we're going to push that down into Snowflake and run whatever query or Python script that you have on it within the Snowflake engine. That's everything that's occurring in there. When we say things are stored there, the computers run there, that's what we need. So now you can see that we've loaded all our data. We have 232,000 records for clean yellow cabs, and we have 4.7 million records for clean green cabs. We've got our read connectors. So now let's move on to the transforms. And so transforms, for those unfamiliar with this in lexicon, just means this is where we will massage, manipulate, whatever you want to describe data transformation with. That's what's occurring. So you're going to be able to move it to however you want. So here, we're going to go from the clean green cabs read connector and create a new transform. So that'll look like this. You left click here, say create a new transform. And then here, we'll just copy and paste again. This will be called augmented green cabs. And in this case, we will copy. So you can just click the copy button here rather than double click and get the query that you want. All right. So this, as I mentioned before, when I said we were pushing things down, that exact query that you just saw, so this one on the left, this will get pushed down into Snowflake and run on its engines there. And so this offers a couple of advantages, primarily obviously being that you are able to use the compute engines in Snowflake, as I've said time and time again. But many other uses come in the terms of what's the cost that's associated with it. Can we audit this? What exactly is happening? What's our query plan look like? All these sorts of things that you're able to do on Snowflake regularly, you're able to do here. It's just not something that we talk about because that's something that Snowflake does. And so it's something you can always take advantage of, regardless of whether you're doing it on Ascend or Snowflake. So from there, you can see that this query ran properly, got all our records, and it didn't really do anything too much, just add a new column where everything is green because they're green cabs. And we truncate or date truncated. This is a function within Snowflake SQL that we ran on it, made sure that we got the date exactly. And this is so that it can match up with the schemas, because if you noticed earlier, these schemas are actually slightly different. And if not, feel free to look at your read connectors, and you can see that the schema generated has 10 rows here. And the schema generated here has 12 rows, right? So then we just clean that up. And now what we're going to do is we're going to create a new transform, all tabs. And we're going to copy a new query that will just union the two now that their schemas are the same. So we'll go ahead and create this. And now you'll see this will run schema inference, getting whatever schema it is, it'll list it, and it'll create the records, right? But what we're going to do right after this is we're going to create a new data flow. And this will show us one thing in particular is that we are actually able to share data between data flows, excuse me. And so what we mean by a unified dev environment, this is what we're referring to here, right? In this particular case, this will exist in the same data service, and we can get started on that process now. So if we take a look at, this might take a little bit to load, but what it'll end up happening is we'll end up popping open a new data flow. And so what we'll do then is we'll create a new data flow that will have a data share. And so this data share will then allow us to be able to share that data from that data flow to wherever we really want. So we can enable the ability for you to share it within the data service to specific people or to whoever exists within that environment, right? So let me check if there is real quick. Stop sharing for a quick second. Just pop this open. It's fixed now. So let me just reshare. Cool. So you can see here, we're back up. And so from there, we have our cabs live demo here. So we'll create the counterpart, which is weather live. Right. And then we'll go ahead and create this. So then what will end up happening here is we've created the data flow. We've done this first step automatically. And then we'll go ahead and create a new read connector. We're going to be using the same S3 bucket, mainly because it's publicly accessible. So again, no issues in using it. Skip and configure manually, copy over everything. In this case, we'll call it weather again. We'll be using the prefix match and matching to all of these. These will also be CSV files with header rows. Go ahead and generate our schema. This one will be much simpler, just 4 rows, as you can see here. We'll go ahead and create this, and then we'll create a couple of transforms so that we get the data that we want, right? In this case, we're still using Snowflake SQL. So weather may be rainy, defaults to Snowflake SQL. We just copy our new query, put that in there, create it. And nice part here is you can just start chaining things together. You don't really have to run. We know that this should run at least. So then we can just create them as they go. A lot of people will tend to wait on it. So you don't have to immediately create it to make sure that things are running as they should be. But since we're assuming that this should run properly, we can go ahead and create this. So then you can see we get 2 million records, and these will run. These are fairly simple queries, just cleaning up the data and getting exactly the rows that we want. But then at this very end, you'll notice that we have this new option, right? We have create a new data share. And so what this data share will offer is the ability to, as I mentioned before, multiple times is share. But this will be the publisher side, so this will be fairly straightforward. So what that ends up looking like is this is called rainy days data share. And you can see that this, because we left clicked, we automatically pick the upstream, but you can pick where exactly it's coming from. But the more important one is that you can choose that all data services can access this data share or only selected data services. So what that might end up looking like is that you're actually able to choose who and what can view it, right? So if you have particular teams that you want to be able to view it or particular people that you want to see, this would be the case where you can select exactly that. We don't really care too much in this case because, like I mentioned, this is publicly accessible data. So I think we're a little okay with anybody being able to view that. So in this case, we'll just copy over the basic information, rainy days data share, rainy days, and everybody's able to access it. Looks good to me. We'll go ahead and create it. And sorry, this has actually already been created within there. So I'm just going to rename it. You do not have to rename it. This should be fine in your environment. But you'll notice this almost instantly pop up with the 2 million, right? There's no listing. There's nothing that has to run on it because what this is doing is it's just saying whatever this kind of temporary table is within Snowflake where we stored the results of this transformation, we're just making that accessible for other people to use, right? So then what will end up happening is anybody who quote unquote subscribes to this data share will just end up looking at this table that was produced by this transform and getting the data from there. So you're sharing this data without any extra costs, right? Even if you don't have a quote unquote unified dev environment in terms of everybody's within this data service, as long as they're within your Ascend environment, they have access to this. They don't need to be within Snowflake. They can even be on other warehouses like Databricks or GBQ, and they'll still have access to this. Cool. So now that we've created the weather data flow, which we breezed through, but it's fairly straightforward when we just wanted to be able to share the data, we can now come back to our tabs data flow and say, okay, we've got the data that we want from weather, but we don't have it within this particular data flow. So how do we get that? We pop this back up and we say connected data share. Remember how we said that was the publisher side of things? Now we hit the subscriber side of things, right? So I've gone straight to this window where I've gone to my data service. You can look it up. So in this case, you can search out rainy days. You can do whatever you need to find it, but this should be fairly straightforward. So in this case, rainy days data share 3, you'll notice that we can subscribe. So this is what we mean by subscribe. You get into the data and multiple people can subscribe to this. This isn't like a one-to-one relationship. You can have as many people as you want. Then we're just going to go ahead and create this. You notice that this data shows up here, instantly gets the records. No time required. Data's already there. Don't need to worry about it, right? So now we'll end up creating our last transforms. We'll go ahead from here where we stopped last time. And then create a new transform. Quickly call this rides with weather. And then here, all we're going to do is we're just going to inner join on the data that we just found and get all the data collated. This is a different name, excuse me. You should be fine. Again, this should work for you. I just have multiple data shares of the same name, which is why that's throwing that error. But you should be fine. This will run in the meantime, but this will probably be the full part of the lab, will be a Snowpark transform. So this we finally reached is the tip analysis. This will be a Snowpark transform. So we're going to change this from Snowpark SQL, which has been the default this whole time, to Snowpark. And so I'll open up a couple options. Don't worry too much about what those mean if you are unfamiliar with Ascend. Just know that this has automatically picked this as the input, but you can select what your input will be. And then you can choose the strategy. For now, we'll just reduce all partitions to 1. Don't worry too much about what those exact details are. Either one of these works though. And then we can go ahead and copy paste. What exactly is this query doing? It's saying a couple of things, right? We want to filter or get rid of anything that doesn't have the tip amount in our particular table. So this table referring to rides with weather. You can see that this table is referring to input 0 and inputs is referring to this, right? It's saying that anything that doesn't have a tip amount greater than 0 or anything that doesn't have a fair amount greater than 0, get rid of it, right? And then from there, now that we have those particular records that are relevant to our analysis, we're able to say we're going to add a new column called tip percentage that is based on our tip amount from before, multiply it by 100, and then divide it by the fair amount, i.e., what is the tip percentage that's actually occurring, right? So if someone paid $2 on a $10 trade, it's 2% or 20%. Excuse me. My math is a little off there. But the idea is that you get your tip percentage now. You're now going to group by in this the fifth line, you're going to group by passenger count. So how many passengers are related in this, right? And so that way we get an idea of what exactly the tip percentage is between the number of people present in the ride. And then from there, we're going to aggregate, get the averages of said tip percentage between those number of people groups, and then call it the average tip percentage. So at the end of the day, what we're getting is for the number of people in a ride, what is the average tipping amount or tip percentage in this case, right? And the thing here is that in a SQL query, this would be significantly more complicated, right? This is not something a SQL query is really designed to take advantage because you want to define an end state, not exactly, oh, from this point to this point, you need to do this and this to get this, right? The SQL query is going to say, oh, I just want to get the average tip percentage between the number of people, but that's not an easy SQL query to write, right? And you might get there in the end. It's not impossible, but it will require a lot more dev time and someone with a lot more fairly advanced knowledge of SQL to be able to take advantage of that. So as a result, we're going to write this Snowpark query, which this is what we're talking about when we talk about taking advantage of the complex nature of Python. And go ahead and create that. This is still running, so it might take a little bit for this to come up. But at the end of the day, what this is going to end up with is close to still 5 million records, but this will combine down to about 9, right? Because there's going to be 9 groups of people. And so from there, that Snowpark query will run, get everything that you need, and go from there. But that's the entirety of the demo. You will now have a fully operational data flow with not only a Snowpark transform in there, but a datashed in there as well. So you get some cool features in it. You also have the option to build another Snowpark pipeline. So if you think only one isn't quite enough, you can still build as many as you want out here. So there's plenty of options for you to be able to do that. And again, this isn't restricted to just ours. If you want to play around with your Snowpark stuff, feel free. Just take the data, play around with it how you so choose. This is just to show you what exactly you'd be using Snowflake SQL for, where you're just joining things, moving between things, so on and so forth, and getting what you need. So we can see here, this finished up, 360,000 records, a little off the 5 million that I said, but the idea is that you still got the number of records that you needed, and then you get the 9 records at the end with the tip analysis. So what does that end up looking like? Take a look. Your records are going to say what's the passenger count and what's the average tip percentage, right? And so hopefully this was a good intro to what exactly you might be using Snowflake SQL, how you might be using Ascend, how you might be using Snowpark, all these things combined into one bite-sized session. But if you have questions, if you want further explorations, we have all these guides that show from everything from more basic introductions to Ascend to how exactly might I use Snowpark in a large capacity. And if you have further questions, we have plenty of time to answer it during the Q&A. But all our developer docs are dedicated to saying, okay, this is what Snowflake does. This is what we do here. This is how it takes advantage of it. And we can always walk you through whatever you're interested in. So thanks for coming today. I think we're going to open the floor to Q&A very soon. Paul will probably lead the charge on that because he's a better MC than I am. But thank you for coming.
And thank you, Ayush. That was a great overview of how you use Snowpark in Ascend and how you can automate Snowpark in Ascend as well. And so if you can imagine, after you built out that really complex pipeline and you want to make a change to one of those pipelines and say, let's update this analysis, right? That's where we really start to see a lot of the power coming through as well of the automation engine and the intelligent pipeline controller allowing you to do that. Amazing stuff. Yeah. Thanks so much for walking us through that. And it was very straightforward. And I feel like I can even do it now, which is great.
Definitely
One thing that kind of came to mind for me, Ayush, when I was watching the demo was, how would you think about performance optimization around some of these Snowpark queries? Are there analytics available? Because you mentioned earlier in the presentation, you are going to need as a developer to keep an eye on some of those types of things. Would you use tools within the Ascend platform to understand which things might be needing optimization? Would you use tools in the Snowflake platform? See that? Like, how would you begin to start unpacking that?
Basically, on the Ascend platform, what you're actually able to do is just check out what your costs might be, what you're looking at on like a component or data service level. So you can get into the observe, or you're able to view different things about what exactly is running. And if you have admin access, which I might not have, you have access to your billing and your job usage and what exactly is running in Ascend, what is costing me money on a component level, on a data service level, on a data flow level, right? So what we're referring to is like pipelines, groups of pipelines, or individual transforms and those sorts of things. Where's my money going? Where's my time going? Where are my resources going? So those are all viewable in Ascend. Now, if you're interested in the particulars of how is a Snowpark query running, how is a Snowflake query running, what exactly is going on there, then you can dive into the Snowflake console and say, okay, what exactly is happening there? And what exactly are my costs in Snowflake going into so that I can optimize there? Do I need as large of a warehouse? Is this query running how I want to? Maybe I should go to Ascend about it and ask, why is this query running the way it is, right? We're not infallible. Maybe your query is running inefficient, right? So you can come to us and ask us, what exactly is going on here? Why is this written this way? And we'd be happy to.
Super. Yeah. Thanks for that, Ayush. And makes sense. So you'd come into that observability dashboard that you shared, which kind of shows resource allocation by job type. And I could see, hey, this particular step is running for a very long time and maybe using a lot of Snowflake credits in the process. And so I could say, okay, gotcha. That might be the one I want to optimize. And then I can start digging in on what kind of libraries I'm using and that kind of stuff. Is that a good summary?
Yeah, that was spot on.
Super awesome. Yeah, that's great. So I'll make sure when I start building these pipelines out, I don't start charging the company lots of money. That's always helpful. Yeah.
We got
Thank you
an
both.
interesting question here. We got, do I ditch Visual Studio Code? So you can still edit your code in Visual Studio Code. No issues there. We do offer a local SDK or CLI, all those sorts of things that allow you for your local development to take off without having to resort to the Ascend UI. So I wouldn't recommend ditching VS Code quite yet, but you definitely have the option to.
Yeah. Yeah, great question. Yeah. And that's one of the things that is amazing about the Ascend platform and Snowflake as well, being extremely flexible and accessible via APIs and CLIs and that sort of thing. Is the way that the Ascend platform is built is you can replicate your entire pipeline as code. You download that to your CLI. You can edit that in your favorite code editor like VS Code. And then you can upload that. You can actually run against a live Snowflake environment from your command line terminal using the Ascend SDK and the Ascend components. So then that's one thing that if you were to try to do Snowpark on its own, it would take a little bit more work to set up your development environment. But with Ascend, it's just a couple of commands to install the Ascend CLI, and then you're off to the races. And then you can just essentially start to write Snowpark jobs, and you can just use the Ascend CLI to execute those against either staging or, if you wanted to, even production environments. If anybody here is that risky, that bold, I should say. But you could do that very easily from the command line. And if you want to develop via the UI that we just showed, you can certainly do that. If you want to develop via the command line, you can do that as well. Tons of flexibility there. Great question. All right. And I think that's going to take us to the end of the session here today. So once again, folks, thanks for learning how to automate your Snowpark data pipelines. If you have any further questions, feel free to reach out to us online. We are at www.ascend.io, and more than happy to share with you a little bit more about the details of this. And if you're a current Ascend customer, you can always use the intercom button within your application to ask for help and start chatting with a support engineer. And we're more than happy to start answering your questions there as well. So please feel free to take advantage of that. And once again, thanks everybody for joining, and we will see you online.